When two shapes are similar, that means that their angles remain the same. So if you enlarge a shape, and that's exactly what similarity means, is that one shape is enlarged to become a larger shape, then in that case we say that the shapes are similar, and when we study that, we see that the angles remain the same. And that's an interesting property because what that's saying is that when you enlarge a shape, whatever this angle measure is down here, this angle measure will be the same thing. And that makes sense actually, because an angle is a measure of how open a corner is. And here we can see that the corner remains just as open, it's just that the side lengths were enlarged. So that's at the heart of similarity. The sides, what happens with the sides is that they are enlarged proportionally. And in this problem, it says that the triangles U and V are similar, and the ratio of the perimeter of triangle U to the perimeter of triangle V is 2 to 5. What is the value of A plus B? So it might be strange to you, if you're used to similarity problems, that this problem talks about perimeter, but really, what is perimeter? Perimeter is the sum of all the sides. So they're telling you that the sum of all the sides from the small shape to the large shape is 2 to 5. Well, if the sum of all the sides is 2 to 5, then the ratio of each individual side is 2 to 5. So if we're looking for A and B, we can find A by saying, oh, the ratio of A corresponds with 15. So that proportion of the small shape to the large shape is just based on the same ratio as the perimeter, 2 to 5. And we could cross multiply and solve for A, and cross multiply and solve for B, and then it'd be very easy to just add A and B and find that total. However, I would like to show a more interesting approach to this problem. What you could do is you could consider, we're looking for A plus B, and we could really think of A plus B as like a whole chunk. So this whole chunk corresponds with this whole chunk. We could say, just like A to 15 is a corresponding part, we could say this whole blue chunk to this whole blue chunk, they're just corresponding parts. And since we're looking for A plus B, let's look at that as kind of just a group of sides. So we could say A plus B. Well, what would that correspond with? That whole chunk would correspond with, well, 20 plus 15. That'll make 35. And that's just one chunk corresponding with another chunk of sides. And we know that the ratio for the sides is 2 to 5. So of course that's just going to be 2 to 5. So you could solve for A and B individually with equaling in a proportion of 2 to 5 for each corresponding piece. Or you could look at A and B as a kind of group like a chunk. So here, A plus B over 35, from combining those, is equal to 2 over 5. Now we could cross multiply, but since we're just looking for A plus B, why don't we just do this a slightly simpler way and just say, we just want to eliminate that 35. How would we do that? Well, we would multiply both sides by 35. So that would be actually a little easier than cross multiplying, because you'd have to divide more in the end with cross multiplying. So let's see. These 35s cancel. Oh, whoops. I didn't mean to cross this out. What happens here? Well, A plus B will equal 2 times 35 divided by 5, which is 70 divided by 5, which is actually 14. So A plus B would equal to 14. Perhaps you wanted to just solve for A and B individually in the end. Well, I hope this is clear and helpful in your study and learning of similarity.